Yo, GM everyone. If you can hear me, just do a thumbs up in the chat. Yeah, it's been a long time. I'll say a long time, but it's been a while. It's been quite a while. And we are here. We're here for another episode of The Anchor Founder. First off, I would say Happy New Year to everyone. It's not technically the first stream I'm doing this year. We had one 3 days of DeFi session. And now we're back on the Anchor Founder account, my account for the Anchor Founder. Yeah. So, what we're going to talk about today is what's our topic again? In 1 minute. What is zero copy? And let me share the link to this podcast in the chat. 1 minute. Uh, Trying to share the link. I'm live. I need to mute this. Oh, a minute. Looks like we are live. Looks like we are live. And I'm sharing. 1 minute. Yeah. So that is that one. What am I? Yeah. Looks like we're live. I made the post there. Let me share this one also. Just want to get everybody in the room before we get started. I think, yeah. Okay. Okay. Now we can get started, hopefully. Okay, so what we'll be doing today is I have this draft here. Let me just speed it up, increase the font a bit. I'll try to make this in the chat so everybody can have a look at it. See, 1 minute. If my PC freeze. Yeah, let me share this in the chat. You think of okay. What screen am I looking at? I think this one goes here. This one goes here. Yeah, we have that one. Chat, Twitter chat. Yeah. Am I still sharing my screen? Yeah, I think I'm not sharing my screen anymore. So let me bring that up back. Yeah, GM everyone. Yeah. Yeah, yeah. Let me turn down the music a bit. Okay. Uh, like I said, welcome to the Anchor Founder, and today we'll be doing what the fuck is zero copy. Permit my French. What is zero copy itself? What is zero copy? And we'll be doing. We'll be touching some breaking changes in Pinocchio. As we all know what Pinocchio is. If you don't know what Pinocchio is, let me search Pinocchio 1 minute. Pinocchio. Yeah, this one. Pinocchio, and I'll bring it over 1 minute. So if you don't know what Pinocchio is, yeah, so this is Pinocchio. Refresh for the image you show. Yeah. Create learner programs with no external dependencies attached. That's what Pinocchio is. It's an SDK that helps you, a couple of SDKs, one and a couple of SDKs to help you create Solana programs that are lighter and less expensive to deploy, to run. It's just a better way of creating efficient programs, right? So what makes all of that thing, what makes all the whole efficiency and less expensive, what makes that happen? What makes that possible? So that's what I want to talk about today. One of the things that's zero copy. So yeah, it says zero copy. So what is zero copy? So if you check here, it enables you to write programs that do not need to repeat simple serializing and deserializing steps. So that means you can read it off of what's there. So that means if you have a program that wants to write to an account. But let me see if I should just do okay. The way this works is with Anchor, with Bosch. So you have an account that's Excalibur, let me do Excalibur, new Excalibur. Yeah, so let's use this one. So now you want to load your instruction. So assume this is the size that is available for you to load your instruction into writing Solana program to load your instruction for the program to handle. So there is a maximum amount of size that a Solana Pro account can take can be. Let's confirm that max size for Solana account. I think it's 10 MB or 12 MB. Let me see. Max size for 10 megabytes. Maximum size for a Solana account is 10 megabytes, right? 10 megabytes. Let's copy that real quick. So now, and you have an instruction that loads, an instruction that uses, let's say, 3 or 4 accounts. So, but let's say at the bare minimum, you have an account that has maybe a signer. Just do this. You have a signer. Yeah, do a pub key inside the account. You have some fees, which is in BPS. I say fees is U16. Then you have a user account, which is the pub key. The fees is this the 16 and just keep going. Let's say mint X is a pub key also. Mint Y pub key. Then you just keep going, you keep going right after. So for this example, your pub key takes up 32 bytes, U16 takes up 2 bytes, pub key, so that's 32. Yeah, where's my T? Oh, T. 32 plus 32 plus 32. plus 2. Why is U16 2? U16 is just divided by 8, right? So you have a standard byte size is that's U8. Just assume U8, 8 bytes is 8, that 8 bit is 1 byte, right? We know. Then U16 would be what? 2 bytes. That's 8 multiplied by 2, right? That's just how that works. So now that's how we arrived at this. A pub key is 32 bytes, a U16 is 2 bytes, and a pub key 32 bytes. So 32, 32, 32, 2 bytes. That's how we arrive at. So total amount for this is 32 plus 32, that's 64 plus 32 plus 2. Calculator. 32 plus 32 plus 32 plus 2. 98. So you have 98 bytes over here. So total here is 98 bytes. 98 bytes for this account. That's fairly good enough. What if you quickly get into an account that has you store a list of pub keys who can be the signers, you start getting into it's an NFT, you store a string inside the account. An account size can easily get into, let's say, 15 or say 50, what am I saying, 500 megabytes, 500 bytes. So you have all this account. Let's say the minimum amount of accounts that you have here is 98 bytes, and you have this account's like you're passing 10 of this account to an instruction. So that quickly becomes 980 bytes, right? So still far away from getting into the maximum size of an account. But the thing is, for for Solana now, the stack. So we know what the stack and the EP is, right? So let's now see max size for Solana stack. Solana instruction stack. So we have the stack and we have the heap. So I think it should be 4 kilobytes. Yes, 4 kilobytes. Maximum size per frame, stack size per frame is 4 kilobytes. That's this. I'm going to arrive at something. I just want to get into the nerdy part before we get to where we're going. Yeah. So maximum stack size per frame is this. A minute. 4 kilobytes. Then maximum size of the heap. So let's do maximum size for Solana heap. Solana instruction heap. I think that should be 32 rather. So 32 kilobytes. 32 kilobytes. Blah, 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 blah. 32 kilobytes. We're going somewhere. Let me bring that here to look similar. Maximum heap size is blah 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 blah. I hope the music is not too loud. Just let me know if it's too loud and I can turn it down if you are still following. Yes. So maximum heap size is 32 kilobytes. Maximum stack size is 4 kilobytes. And the maximum size of an account is maximum size of account is, we confirm that that's 10 megabytes, right? So let's do size of an account is 10 megabytes, maybe bytes, but assume is megabytes. Maybe bytes. Just a more granular way of writing kilobytes with more megabyte with more space. Basically, you can look up difference between maybe bytes and megabytes. It's maybe bytes. So it's megabyte. So you can look up the difference between those two. It's closely related, but not exactly the same thing. All right. So where do we want to arrive at? You have 10 accounts now. You want to pass 10 accounts to this instruction, and those 10 accounts are 908 bytes. 908 bytes. So But we have for the maximum stack per frame, we have 4,000 bytes, right? Now, you could, this is just a small account, you could easily load up all the 10 into the instruction stack at once, right? That could You could do that. But what if you get into an account that now has, let's say, a 1 KB account? That's possible because your maximum account size is your maximum account size is for 10 megabytes, right? So let's say we have a 500 KB account and we want to pass 10 500. I see. What was it for? 1 kilobyte accounts. I want to pass like let's say you want to pass x4. That would automatically give us a stack overflow. Let's say we want to pass x3. Or we need to pass, let's say we need to pass x3 of this 1 kilobyte account. We would want a way, because we actually need to have this account on the instruction. We would want a way to have all of this account fit into this mom size of, so you have this, and this one is 4 kilobytes, right? 4 KB, 4 KB stack. You have a 4 KB stack, and you have three 1 kilobyte accounts that you need to pass to the instruction. How proper serialization method works with Anchor, with Bosch, it copies these accounts and loads them onto the stack, right? It copies all the accounts and load them into the stack. Let's say you have five. Let's assume you have five 1 kilobyte accounts. Let's just think. You have uh, you have five 1 kilobyte accounts that you want to load to an instruction. So it finds a way to, now this one cannot get into the account because there's no space for it, right? 4 kilobyte stack and you have five 1 kilobyte accounts. What do you do then? So if you are writing Anchor, you could do something like, assuming you have an account, which is your normal struct info, then let's call it my account. This is what it would look like if you're writing Anchor. I want to load an account into the instruction. But now that we have five 4 kilobyte account, there's no space for the account to get into the stack, right? Get loaded into the stack. What you could do is you could send it to the heap. You just do a box there. Then you can now load this account safely on the heap, right? So because the heap size is 32 kilobytes, right? So you have enough space to do that. But now all of this loading, unloading, copying the account, that's to copy it, then load it into the stack or the heap. It gets pretty expensive really fast, especially when you're getting to large amount of instructions, large amount of data account being loaded into your instruction. It gets very expensive fast. That's why it's an instruction on Anchor, writing an instruction, maybe instruction for a swap could take $0.5 or $0.2, whatever instruction, depending on the complexity of the instruction, right? So that quickly racks up and becomes expensive on uh, the amount of lamp ports that the instruction consumes, right? That is because of the way the accounts are loaded into the stack or the heap, because that should be copied. You get the account, you load the account, and you copy it onto the stack, then you use it there. That gets pretty expensive. So there's a better method to not do the copy. So that is what this zero copy basically is about. Better method to not do the copy. So I'm not copying the account. So whatever, if you have this big account here, my mouse is tricky today. So you have this account now. You do not need to copy the whole account. You just get a pointer to the account and use that pointer for all your instructions. So now you're working with, are telling instruction, okay, this instruction, there's a pointer to an account somewhere. Do not copy it to the stack or to the frame. Just know that there's this account. So you can read from it and you can write to it. So that is basically the simple ideology be with zero copy. So now you don't need Bosch. You don't use Bosch. So Bosch does a lot of copy. Bosch is what Anchor till now Anchor uses heavily. Anchor Metaplex still uses Bosch in their MPL core. Every program about before Pinocchio used a heavy method of copy. So and that mostly Bosch, right? So now that there is Pinocchio, this is how that works. So now I think I've gotten any questions about that. I think I've explained all about copy and zero copy. So now let's read. Pinocchio give us raw no STD access. That means no standard library access. So combining it with this zero copy crates is the prime way to keep compute budget very low. So now, what are the crates that we're looking at? There's a lim code is not lim code got deprecated or something. So for the zero copy crates, these are the ones that we can choose from: ByteMock, zero copy, win code, and archive. This archive RKYV, and we'll get into all of them into the maybe not all of them, but we should maybe in this series throughout the week we can touch all of them. So let me edit this. Let me edit this. I'm going to remove limb code because limb code was existent before it's not existing anymore. So now I don't know why, but I can't find limb code anymore on the crates.io. So let's just remove that. Maybe it was deprecated for a beta release. Yeah, update public. Just I have a typo here. If we are trying, so let's just get into it. How would you write a Pinocchio program? Everybody knows how to write a Pinocchio program basically. It's just like writing raw, like writing vanilla Solana programs with the Solana SDK creates without Anchor. That's what Pinocchio is very similar to that. So this is what it will look like. I have okay. Let's see the document. Pin then code that I think yeah. Okay, so this is what's in your. But if you want to create a new Pinocchio project, you could just do a project, just a Rust project. Basically, you just do cargo new. Then name of the project is let's say my name, whatever, and you set it as lib. So yeah, you're creating a lib library. Not just you will not have a main.rs, you just have a librs basically. So this is just what you need to do to create a Pinocchio program, right? So once you've done that, then you start putting in the dependency that you're using. So for this, we'll be using this. Let me bring it back. Yeah. So you can just add Pinocchio. That's 0.10. That's the latest version. So we're going to talk about breaking changes also. We're going to talk about breaking changes in Pinocchio. There's now is a more standard version of Pinocchio, and all of the pub key was removed. Account info was let me just show what that looks like. So immediately in your librs, you see we don't have pub key, we don't have account info, we have new things now. So let me show you what the tree of that looks like. Timeline 1 week ago. Yeah. Um, uh, so if you look closely, you see we used to have account info, we used to have pub key, but we don't have account info and pub key anymore. So we have account view and we have address. There's a couple of reasons behind why those were removed, and it's also contributing to efficiency. Our account info is now account view. You will get into it, but I just want to give you a heads up on the breaking changes that are in Pinocchio. If you've been using Pinocchio before and want to bump up to the 0.10, yeah, this is the first thing that will greet you. You don't have account info anymore. You don't have pub key anymore. It's now account view. I have address. Pretty much. There are also some detail things that were removed, but that should be good for now. Config. So now let's get back to our guide. So we have our crates. You can remove this. This is now exported inside Pinocchio. So instead of pub key, it's now Solana address. You see also if you're using GIL or using Kit, you see there's no pub key anymore. It's now they are called address. So there's this new change. Everything is moving towards address, address, address. So Solana address is also exported from the new Pinocchio 0.10 with this curve feature, this curve 25519 feature enabled. So I'm going to try out a couple of the zero copy libraries. I'm not using Bosch. Bosch is copy, right? So ByteMock, zero copy, archive, Wincode. Um, so and there are some constraints with them. No, now you've removed. You want to do efficient work, right? So is going to be some. Yeah, JM Alejandro. If you want to do efficient work, there's going to be some what do you call it, some critical thinking that you have to do as a dev, right? And there are some constraints you have to work around. First one is you can't you don't have Vex. You cannot use Vex directly with ByteMock. You could use Vex directly with Wincode. You could use Vex directly with Archive. Or with ByteMock, you need to think fixed array size. That's what you need to think. If you want to just say you want to have a program that takes in an account, you can grow the amount of signers, let's say to you have authority in an account, right? So and you want the authority to in the future, you just create a vec and you want to keep pushing to the authority and popping from it, push, push. That's a growable array. No, with ByteMock, you can't directly have that. You need to use a fixed size array. You need to know upfront. Do I want this array to have a max size of 5? Do I want the array to have a max size of 10? So you specify that upfront in your account struct. So that's what that looks like. And also with ByteMock, you don't have options. You don't have sum. No, you could just basically put a sum and a none in in an account because if you are creating an account with Anchor, you could just put inside the Anchor initialize. Let me show you what that looks like. A minute. Yeah, I'm already getting into the nitty gritties and I wanted to skip before getting into it. So let's assume all of this did not exist, right? Let's assume all of this did not exist. Let's do a pub first struct. First account. Now, how do you tell the compiler that I want to use this method of serialization or this method of serialization? I want to use this particular uh, SDK, this particular zero copy SDK. You just derive it based on so you derive for ByteMock. It's the tool that we use is pod. That means plain old data and zeroable. Then we just do clone and we do copy. So and for this to work, you need to do a RPR representation C. So it just means treat this how C aligns the bytes. Yeah, so that's basically just take it as that for now. You can get into details later. So we have pod plain old data. This macro ensures that the struct follows all the safety requirements for a pod trait. Yet, so what are the safety requirements for a pod trait? Let's think. Is that so? Not pod, phantom data, E32, 4E32, uh, generic struct not pod. Okay, okay. This one is not a plain old data because there's no defined variables inside the struct. It's just a struct that I created out of the blues, right? So this will not go. There are a couple of things that are not pod and zeroable. Let's just start with that. First, let's do pub. Let's say you have authority of the account. Authority of the account could easily be a. If we had pub key, we just have a pub key and we're good to go, right? But some people want to take it a step further, and instead of writing a pub key, just tell us the size of the data you're keeping inside of it. So, and a pub key, like we said, is U8 and the size is 32. So max size of 32 U8. That's what an authority is. That's what a pub key is. A U8 with a max size of 32. Fixed size array. You want to know the exact size at compile time. Cool. So what if we want to make this authority optional? So let's do it this way. Some authority. So is probably we don't want to have an authority in it. Probably want to have an authority. You immediately get this error. Expected type found variant some, not some. I wanted to do option, option, option of U32 and that. So you immediately get an error that says pod in option is not satisfied. The following blah 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 blah. Blah. Yeah. So you cannot use an option type on a plain old data and a zeroable data. Maybe if you use non-zeroable, is there a non-zeroable from let me do zeroable? Let's check bytemark. So you start seeing how you need to think of change the way you think when you're writing zero copy programs just to get the maximum efficiency, right? Efficiency out of your programs and to reduce the compute units basically. You have to think differently. Is there a non-zeroable or no pod? We are using pod and zeroable from bytemark. So you immediately do not have option traits. Then let's assume you have, let's say, an enum as authority. Enum as authority, and you say true redundant, but false. That's the problem. Put it in a pub, enum. That's wrong. Yeah. So that's a repeated an item. Oh, imom. Enum. My bad. So you have this, and you want to use it inside this. Let's just say pub as authority is as authority. Now you get an error with the copy and clone. So cannot be implemented for this type. So let's say we want to take it a step further. I want to make the compiler think we know what we're doing. RPRC, or let's do a U8 RPR. But U8. We still get this error that clone is not satisfied now because you cannot clone it. So let's see if we derive clone. Derive clone and copy on this. Still have this error. Bytemark pod is not implemented for as authority because zeroable is not satisfied. This is not a zeroable entity. What you could do, you could use a struct there, that would work. Have a struct. Let's do mod as authority. Let's to RST as authority. Then 1 minute. Yeah, obviously, I'm just telling you the workaround we could do for this. So I do pub pub true plus 0 pub I think pub false equals 1. 1 minute. Instead colon. Okay. How do I want to do this? Let me say I put in a const. Yeah, pub struct as authority. Yeah, let me just do pub struct as authority. Then I do an implementation of as authority. Implementation as authority, and I do const const true, which is a U8 equals 0, and I do another pub const false, which is a u8 equals 1. Now I could, because our authority, 1 minute, okay, 1. Uh, 1 minute pod. So now I could use it here, but it's still not an enum. It's just a struct, but it's working as an enum. So I could do a pod here, and I could do a clone. Will pod work? I think it's zeroable. That would work there. Zeroable. Yeah, it worked. So now I could say if I want to use it anywhere, I could say as authority. Let's new status, because as authority true or as authority false. That would work. That would definitely work, because now we just did a walk around for an enum, because we cannot have an enum, right? So we did a workaround to make ourselves think we're using an enum, but we're not using an enum. It's just an implementation and a structure, right? Cool. That's the way you would do it if you want to do a workaround on ByteMock, because you can't have non-zerable elements, non-zerable entities, or what's the word, arguments. Or you can't have non-zerable things inside a ByteMock struct, inside ByteMock POD struct, right? So that's the way you would do it if you wanted to do something like an enum derivate. So what if you wanted to do boolean? Definitely can't say it bool there, because it's not pod. What you could do there, you could just put a u8. So the u8 could be 0 or 1, so that would be true or false, right? That solves it. So we'll say this could be a bool, right? So yeah, there's just a lot of ways. You now have to think of better ways to do this thing. I'm just telling you how you need to take your time to, but once you do it multiple times, you just it feels natural for you to store accounts, to create an account. This is the template for an account, right? We could also do it this way. U8, then 1 as the size. You could do it this way also. This is also fine. Same thing. So, or we could do it this way, like I said, right? Then what else was I saying we could not do? This is this is a pub key. This is as authority, this is a boolean, which could also be an enum. And what else? And every other thing goes, right? You ought to have your pub fee. Your fee could be a U16. So U16, you could rewrite your U16 to be this U8, and U16 is just 2 divided by 8 divided by 2, right? So that's is 2. That's fine. So now, before I get into all the caveats here, let me show you what it will look like if you did not know what I just said. If you didn't know about what I just said previously. So using which one? Using ByteMock, yeah. So this is one example. Let me copy this and let me show you what that would look like, because we also have an error there. Let me just get you confused now before we start arranging everything. Cool. All in favor say aye. So we have this. Now this would fail. Let me comment this out. Why? Let me remove the comment so you don't know why. I want to tell you how these things are aligned in Pinocchio. In Pinocchio, in ByteMock rather. How the bytes are arranged. So let's say you're a cool guy, you just come to ByteMock and you say, okay, now I know I can't do this, I can't do this. Let me just create a struct that holds 3 numbers. The first number is a U8, second number is a U64, third number is a U16. This should be fine. This should work well. But no, it does not work well. You see, you already have an error here on pod. Evaluation panic. Pod was applying with a type with padding. What is padding? Thing is, like I said, like we said, the stack and and heap. So when you're writing data to the stack heap, we need to know how these data are packed, because if you have a struct, if this struct eventually goes through on the heap, this is what it will look like. It will look like this: the first U8, then the second U8 is 8 U8, right? U8, 8, U8, U8, U8. Uh, yeah. So this is the first, that's one U8. Then the second number is this U8, that's 8 U8, right? 8 bytes, that's 8 times 8 is 64 now. Then U16, that's U81, another U82. So this is the U64, this is the U64, my mouse. This is the U64, and this is the U8. This is how the data is arranged. This whole struct, this is how it is represented in memory. So, but this struct gives Rust the ability to know what's the beginning of this, what is the first thing inside this group of bytes. If it's aligned properly, this is what it looks like. First inside the group of bytes, the first the first number will start at a U8 index 0 and end at index that's 0. The next index 1 to index 8 would be the U64, and index 9, index 8 to index 12, 8, 12, 11 would be the U16. So that's just how computer interprets memory basically. So it just stacks everything up like that. So your struct now tells it, okay, this is the first byte to point to when you're looking for the U8. This next 8 bytes is the U64, then the next 2 bytes are the U16. All right, but this will not go because it needs to be packed in a set of 8 bytes. If it's not ordered well, it needs to have this solid structure that you have at least 8 bytes or divisible byte pack. So this U8 here, I have a U8 here, that's one. Then it immediately sees another U8. But this is just one, it sees 8 bytes, but this one sees just 1 byte. Immediately sees 1 byte. It needs to balance this some way because it needs to be in a pack of 8 bytes. So it then automatically adds, it needs to add 8, needs to add 8 bytes padding here. Right? When we have 7 bytes padding here, rather, needs to add 7 bytes padding here. Here. 7 bytes padding here. So that makes this 8. Now it's fine. Then we'll have the next 8, right? But maybe the next 8 packed, it now sees another 2 here. So it's still aligned. You need to align it to have, you need to add, I think now should be have 6 bytes extra as padding. That is the problem. That's the problem, right? So how do you immediately fix this? If you don't want to know about all paddings, how the paddings work and all, you can immediately just arrange the bytes in the order of from the highest byte to the lowest byte. So it starts packing them tightly from the top. So that would be U64, then a U16, then a U8. So that way you should be satisfied. We do this, and we save. Now it should be satisfied, but we are almost there. Now we are no longer concerned about the pack of 8 bytes anymore because we have arranged it in the order of increasing magnitude, right? But we still have an error here. There should now be padding. This is 8 bytes, 8 plus 2, 10, right? Then 10 plus 1, 11. Bytes is not divisible by 8. So that will be a problem. So what we need to do is just padding. Then we pad it with 11 minus, what's the next number divisible by 8? That's 16, right? So 11 minus 16 is 5. So we could pad it with 5 U8s. Yes, another troubles go away. You understand now? That is how it would work. Because firstly, we fix the first error of How do we align? The big one comes before the next one. So that takes the first error away. And the second error is now that I know that you've arranged it, is it now tightly packed to be divisible by 8? So that's why we need to have this padding. I think if you do it like if you did like you have one U8 and another U8. Let me just do that. Let me do this way. If it would allow us go. So 1, 2, 3, 4, 5. But then let's see if that will work too. So just to tighten everything up, 2, 3, whatever. See if that will work. Yep, that worked because we had 8 plus 2, 9, 10, 11, 12, 13. Sorry, 8 plus 2, 10, 11, 12, 13, 14, 15, 16. Now it's now tightly packed as. But now, the best way to do this is if you don't want to bother yourself about knowing what size comes first, what size comes next, you can arrange it however you want. Just represent them as the same way they will be tightly packed in memory. So that's a U64. So U64 is 8 U8, right? So we have U8 and we have 8 here. U16, this should be U8 2, that's 16. The next one will be U8 1. You could just write the U8 there, but let's say U8 1 size. And all the troubles go away. Now, it does not care about is it packed or not tightly packed because you already specified the size of this as early bytes. So you specified what, so it will just automatically create assign this space for you on the stack, on the heap, depends on what type of data you're storing. So this one it will assign this data for you on the stack, right? So all clear. I think that's clear enough. So let me now walk you through the story that we wrote here. The story we wrote here is yeah. So I put comments there to explain why the three won't work. Okay. So the first one was this unordered stacks. U8 comes before U64 and U16. It's not ordered. So next we order it U64, U16, U8 is fine. But when we sum everything up, we now have 11 bytes. But it needs to be divisible by 8. So for it to be divisible by 8, we need 11 minus 16. 16 is divisible by 8. So 11 minus 16 is 11 minus 16. Sorry, 11 minus 16. Yes, that's 6. 11 minus 16. 5. 11 minus 16, 5. So we need to pad it up with 5 bytes. So that's why we did it requires padding of 5. So increase the alignment from 11 to 16. And that's what we did here. We just padded it with 5. And total 16 divisible by 8. This is the raw method approach of using win code. So that is the way, if you're using something as strict as win code, let's say, shut down the strict as win code, let's say transmute. Yeah, transmute is very strict like that. Win code, then zero copy. If you're using zero copy creds, also you need to do it that way. Let me get 1 minute. Yeah. Am I still live? Yeah. So let me get what that looks like. So that's what that looks like here. So now I based on what we're saying, this is using byte mock. Let me copy it away from the rest so it does not. We have this guy. So what this is because we cannot have an option here. So we can just first start the data with a flag. Is there an authority here? If there's an authority, then later we can now, when we're doing the logic, we can now check for the authority. So this is authority can only be 0 or 1. Then the authority is now an array of, so it has max of 5 arrays, right? A max of 5 pub keys. That's what this one means. This one means you can have pub key 1, pub key 2. So just create space for 5 pub keys. Pub key 1, then pub key 2, and pub key 3, pub key 4, pub key 5. So this is what this means. It just means if we add pub key here, this is what it will look like. Create pub key. That's what it looks like. But what is the size of a pub key? This is the size of a pub key. So that's why we add that there. Yeah. Yeah. So then token X, token Y, all of that there. So that's how you would create your your config account. Let's say you have creating an AMM. I want to represent the data. You want to create an account struct for the data for the account. This is how you would do it with ByteMock. Then how do you read and write from it with ByteMock? I'm going to get to that. So if you are using zero copy, that's zero copy cargo.toml. We have archive. I just talked about ByteMock. Then we have zero copy. We have win code. So if we're using zero copy, this is what it will look like. Config rs. Let me comment this one for win code. 1 minute. So yeah, if you're doing, like I said, zero copy is strict as ByteMock also. But we could do a benchmark. These two are basically the same data struct. So do a benchmark to see if we created an account with this or created an account with this, how many CUs which one of them consume, right? So same thing as authority, because you cannot do a boolean on, can you? Let me see. Do a boolean there. Throw a boolean there. Yeah, from byte immediately panics and shouts at you. Trace bool from bytes unsatisfied, derive from bytes to bool, blah 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 blah. Yeah, so we can't use a bool there. So we do it the same way we did the as authority for here. And we cannot use vectors. Let's see. Comment this out. A minute. So assume we want to have a vec of, let me just do vec of u832, a growable vec of u832. Yeah, you now have an again with unaligned, shows you an error. STD vec. Basically, this is an STD crate. So, and when you know STD environment, so no vex, right? The problem. Yeah, unaligned says STD vec is not satisfied. Unaligned is not satisfied for STD vec, so that doesn't go. Then just from byte also, let's see STD vec. STD vec u832 cry from byte is not satisfied. So you cannot use a vector here with either ByteMock or zero copy. Let me share. Okay, why? Let me share what those look like. Max size. So let's do zero copy crate. You just look at the crate to see, and the GitHub to understand what's going on in the crates, the motivation. The one I really want to get is archive. It's pretty new and it's interesting because you can create dynamic arrays. So it's very efficient with creating dynamic arrays. This one, let me just show you. ByteMock, sorry. Archive create, yes. Yeah, it's no STD, zero copy. So you can see that this has zero copy and no STD create, but it gives you the ability to create growable. Yeah, you can use an option and a vec in archive. So if you don't want to stress yourself with ByteMock and all those scary stuff, you can use archive, and we'll get into using archive. If not today, I don't think we can finish that today. But to be a series, right? So to be a series of everything, and we can get into that at the end. We have Monday, we have Wednesday, we have Friday. So to be a series, and I also want to get into zero copy with Anchor. So this one is for Pinocchio. This week might be for Pinocchio, guys. The next week might be zero copy with Anchor, guys, because there's also a very good way to do zero copy with Anchor. Yeah. So this is the one I'm very interested and excited about, and we will get to it maybe tomorrow. But let's just see how working with ByteMock is. Then also uh, zero copy. So now we now understand. Then we can talk about win code tomorrow also. Win code, we talk about, I think we're talking about four or five. Where's we're talking about ByteMock, zero copy, archive, and win code. So we are going to benchmark all of them to see which one is less expensive and the most efficient for what packages. Like I said, if you are dealing with fixed size stuff, you already know the maximum size of what you want to do in your programs and use ByteMock and zero copy. Or if you are dealing with variable length, variable size of vectors, variable size of pub keys and all growable stuff, you can use archive or win code. So let's get into ByteMock and zero copy right away. Yeah, yeah. Yeah. So that's what the config looks like. Just config ByteMock and config zero copy. Let me do a quick implementation for them. If I want to convert implementation of config ByteMock, you can get the size, right? Pub const size. Let's say if you want to know the max size of this struct, you could basically just use this way. Use 64, use for size. No. So you can use, let's do memory is memory size of this is from core memory. Okay, core memory, then size of, and specify what size, what is that, does it take a truth? Yes. What struct are you getting the size for? We're looking for the size of config ByteMock, right? So just put config ByteMock there. Config ByteMock 0 for found this size. This is for user size. Yeah, and we now can just say dot size. We can definitely get the size of that. And let's now do so let's say we want to create a helper function for this size. Yeah, pub, let's call it size, a function called size. fn size is taking in this guy as a mutable, not mutable rather, as a slice of it, and it's going to return a U64. Right, U64. Now we can just do self size as U64. Whatever reason why you want to do that, record dot size to give you U64. So what if you want to convert all of this data into bytes to use somewhere else later? So we can have a helper function to do. So you can have pub fn is going to take in self as non-mutable, and it's going to give us, now the interesting part, it's going to give us, now we need to know what size of wherever creating, right? So it's going to give us a vector, not a vector. We could do vec, it's going to give us a vector of a vector of u8, right? We could do that. It's going to give us a vector of u8, that, but let's not use vector. Let's use fixed size. So we can use, it's going to give us an u8, right? And what's the size of the u8? That could be self size. I think that should work. Yep. So that will work. Then we can now do, I think, ByteMock size, ByteMock, that's the word, bytes of, yes, bytes of self, I think. Found reference, yeah. So this gave us what we wanted to do, but let's do, because we want to know the maximum size, so let's do, we want to know the maximum size because this has to be cut into the same size, right? So let's do dot try into dot expect, I think there's an expect there, expect a wrong account alignment. Well, we cannot eat that. I don't think we can eat that. So this is array of, a minute. I think that's the stuff. Yeah. Yeah. Yes. So yes, that works. So you can convert this to, so it will just give us all of the data that we have here as bytes. So let me do an example of what that should look like. Let's do a test here. CFG test. Let's call this mod mod C test. Byte mock test. Let's do mod byte mock test, and let's config first config equals cell byte mock, config byte mock, config byte mock. We create this, then we do this. We could have a new, actually we could just have a new function here, but let's assume we don't have a new function, a new method on it. So expected item, no problem, const, oh yeah, const. So let's do authority is pub key, is it pub key new? I think there's a pub key. I think this one converts a string to a pub key. So let me just do, maybe I can still see my screen. Address new, is there address new, mean marks to own deserialize format. Let's see again. Okay, I'll just pick a random account. Let me just do that. Solana address. Yes, let me just use this guy. So address then from string const, and I can do this. I think it should work. Nope. Blah, 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 blah. Expected U8325 found address from string const dot, sorry. So now we have an array, and let me just make it one of that instead of all of that. Create 5 arrays from this. So let me do a function. I come in and just a quick function. Let me see if that should work. Array dot from array, okay, array from function, yes, from function gives me takes whatever and returns this guy. I think expected the semicolon. 1 minute. I don't need this. Yeah. So I think this should do. So yeah. Mm, 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 mm. Oh yeah. 1 minute. Let's five. I don't just want just me being critical. Five arrays equals to this. So there should be a way to specify yes array from this. I think from function t. What's the size of yeah? So this then I'll do 5 as the max, but it would want me to don't put this in this, just do this here and just close it here. And then close this one too. Okay, so Rust is tricky. The array expected an item. 1 minute. We get to the root of this. Is this syntactically correct? From function, you tell me the type is just the type is U8 of 32. Yes, U8 32. Oh, they expected the semicolon here. Nope, that's a comma. F is different. Okay. I think I want to do. Eh, let me just do this. Let new array because array dot repeat create an array of type t by declaring a value. Yeah, I think this should work. This would also work. I'm not just getting the syntax right correctly. So repeat giving me I want this to be an array. It should work. Let me take this off. Let pub key equals this. Yeah, I want to do pub key. No, not here. Pub key, pub key, pub key, blah 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 blah. Consider static. I know, bro. I know, right? So this should work. Binding. Okay. Config bytes make. Now we have. So repeat does this pub key roots have 5. Okay. Pub key. No, not you. Pub key. There, that repeat. So let me put inside a test. That's what is causing the first problem, not the major problem, but the first one. And tests. Now we have function do array, and that just returns this. Let me move all of inside. Yeah, now we have nicer errors, not a big one. So yes, expected use size found. Yeah, pub key should tell. Okay, using array repeat. Using array repeat in Rust. Let me just do not that one. Do this one. Let's see if we can do array from function. Okay, okay, 1 minute. Let me consult Gemini. I didn't want to, but let me. Up, clean up. It's not time. So we have 1 minute. Might be difficult. Might be not. I think we have solution. Probably not. Do we have a solution? 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 I'm still thinking about it. I think okay, I'm in the pro version. That's why it's taking so long to think about the solution. Take your time. Take your time. Take your time. Yeah. Because repeat expected count. Yes, I know we're supposed to put let authority request pop. Oh, I should have just done something simple, bro. It's crazy. I just figured out how forgot to do. This is just crazy. Let's fix the array. Let's call it fixed array. Fixed array is of type U8 of type this type. I need to have this type and it would be 5, and that would just be I think you could do vec. Could you convert it to vec pub key? Okay, you just do pub key 5. I think that should work. Should that work? Pub key repeated. Well, let me own it. And now this is a problem. The bribe valuable. Blah, 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 blah. Copy this from here. I know it's a problem. Put it here. And let me remove this one. There's a problem. Expected this, found this. Yeah. Then do not do that to it. Thank you very much. So now we have 5 arrays after 5 years. Fixed. Fixed array attempt to use a non-transferable fixed array. Then he has authority. Yes, he has authority. So let's do 1.2 early byte. One as a U8, one as U8.2 LE bytes. The next one is token X. Same token X, bro. Not stress me. So let me do this for token X also. We have token X. That's one. My bad. Token Y. Also, we have that one. Yes. Now we have issues. Expected this, found that, then do not expect that, and also do not expect that. Yeah, cool. So we have our first config after 5 years. So can I do first config dot 2 bytes? Yes, we have 2 bytes. Match type. Am I returning? I'm not returning it now. So let me just let me log what this does to it. Print, and I need to derive debug. Print ln, and I do this, and I do this. on 2 bytes. Let's see if our code works. Now what's the error? Does not implement display. I think I did debug. Oh, okay. Then I'll do this. I think, yeah. If I run this tests, like 5 years to run. Now we have an error. Okay. There was an error in librs initially. Librs, where are you? Where's the error? Remove this one. Oh, I think I know what the error is now. Let me just do. Then we have address, then declare ID. Say declaring address. I don't think so. So we need to get this guy back into our cargo.toml. Standard address. Yep. That should fix the error. So in our initialize rs, initialize no. In our config, I want to test. I want to test this. So let's run this test again, and hopefully it should be good. Yes, beautiful. So this is our struct that we just created as raw bytes. So that's what I was trying to explain. That in memory, everything is just raw bytes. Your struct just helps the Rust analyzer to point to, okay, from this first address to this address is a boolean. From the next address to this is authority, an array of authority. So you see, if you convert it to bytes, you're not seeing one array then another array. It's just all bytes. But when you use, yeah. So let me remove this. Okay, terminal, go away. So let's say I want to load this account with ByteMock. I could do, let's new account. Let's say I'm loading the account somewhere else. Loaded account will now be ByteMock. Think read, there's a pod read unaligned. I think there's pod read unaligned. Yes, pod read unaligned, and I'm going to, okay, not here. I'm supposed to do sided tests. So we have our, let's do that out of there. And we have this. So this is byte more unaligned, and the byte is first config. A borrow of first config. A borrow of first config. I think the borrow work. That's dot so let's do config byte mock. Then now I'm using byte to read it. I want it to be quite the first config. Then I can now do dot 30 dot size dot token. So I can do dot token x to get just the token x. Remember, there was no way to serialize, but okay, I could just, when I to I load the account, it can now use by no data rate unaligned as a config by right. A minute. So done. Just taking our time to play around and how zero copy, how data are allowed. It is this. So let me that one out too. Tomorrow get to, but now that the basics are out of the way, rather, let's it's available. So now I should get a is what the amount. Yeah. So basically, that's how we would read to try to eat inside the program. Instead of load it, load it that one count is byte. Then I think um music from the yes have the put in uh, the 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 item. We have that one is the sound. I mean it's there. But I do found I don't name that uh, uh, you know what I didn't immutable fig. Back. Sorry guys. The weather is interfering with the network today. I hope you can. Yeah, you can hear me. Yeah, so let's see. What was I trying to say? I wanted to implement a to byte mutable. Terrible weather today. But I'm going to return. I think we have bytes of mute here, and I can just return a mutable reference to that one. I'm going to return. So now I'm going to take it self and do a mutable reference to self. Just the mute here. That should so now I can do dot to bytes mute. Should solve the problem. Yeah, and I can modify what I want. So I can do mutable account dot token X is now a different token. So let me do let me do okay, let's do this one that we loaded now. Let's make sure we actually loaded it right. Let's do address address then from array. Yeah, new from array. This, let's see if we printed that out, if we would get the same account back. We should. And we got, yes, we got it back. So let me use a different account now. Let me do okay. Let's do keygen new. Is there keygen here? There's no. Okay, let me put it in the okay source. Then I know. So I should have given it a name. Let's call it key pair.json. Yeah. Yep. So we just created that account. So let me find the address of that account. Address key is what JSON file do I have here? Test key pair JSON. So Lana address this address double S. Yeah, so let's use this one for mutating. So let's change token X is now equals to the address from string constant, and we do this one. Yeah, that 2 bytes. Yeah, that should work. So I set it here. Now let's log out what the new address is. Address new from array data token X. So I need to put this above this. So let's test now and see if the address if it did mutate it. ECX, it did not mutate it. That's not what I want to do. Okay, if this is mutable, token X is this. Token X. Oh, I think I know what the problem is now. Not in a Solana environment, right? So if we do any mutation here, well, let me see if I can try to replicate. Not in a Solana environment. So modifying an account here does not change anything on the stack. So let me see. That's to byte. We have to byte mutable, and from it we have the token account. To byte mutable. Okay, let's meet. I think that's going to be mutable. Let me see. Well, over the time we should spend already. So we can just leave it here and pick it up tomorrow, though. But let me Let me build this now. Run the tests because it started late actually. Yeah, still did not modify, but we'll pick it up tomorrow. So that's introduction to it's more than an introduction actually to zero copy accounts and zero copy method of writing loading accounts on Solana, right? Yeah. So thanks everyone for staying. 1 minute. Let me share presentation. And this has been the Anchor founder. So meet on Wednesday, same time. Have a wonderful evening.